So let's take our next question, that is question number 10. The question you see here belongs to section of electromagnetism of chapter electromagnetic waves. Now as per the question, a plane electromagnetic wave travels in free space in positive x direction. The electric field component of the wave at a particular point of space and time is 6 volt per meters along y direction. Now it is important that the wave is moving along x-axis, that is positive x-axis, and electric field is along positive y-axis. Its corresponding magnetic field of component B would be, so we have to find the magnitude of B as well as the direction of B. So in order to find the magnitude of B, we have a very clear formula with us, that is at any point of time the ratio of magnitudes of electric field and magnetic field would be equal to speed of the electromagnetic wave, which is c, that is equals to 3 into 10 to power 8 meter per second. So B would be equals to simply E by 3 into 10 to power 8 meter per second. That would be equal to 2 into 10 to power minus 8 Tesla. So we have the magnitude of the magnetic field with us. Now what about the direction? So if you want to understand the direction, we should go by this diagram, that this is positive x-axis, this would be positive y-axis, and this would be positive z-axis. Now x, y and z. Now it is given to us that the wave is moving in this direction. This is the velocity of wave. Electric field is along positive y-axis, like this, E vector, right? Now if you properly remember that the direction of wave propagation is given by E vector cross B vector, right? So we have to do the cross product of electric field and magnetic field. So this electric field should be something falling on this for the cross product, and the wave will go in this direction. So the magnetic field should be along positive z axis only. So the magnitude would be 2 into 10 to power minus 8, and the direction would be positive z direction, positive z axis. So option 3 is the best suited answer here. I hope you have understood this question. Let's move on to our next question. Now the question you see here, that is voltage rating, this belongs to section of electromagnetism of capacitance. Now voltage rating of a parallel plate capacitor is given as 500 volts. Its dielectric can withstand a maximum electric field of 10 to the power 6 volt per meter. So potential difference between the plates has been given to us and the electric field is given to us. The plate area is this. What is the dielectric constant if the capacitance is 15 picofarad? Pretty simple formula based question. Let's start with the solution. The question is asking for the dielectric constant's value, and we know that C is equals to K A epsilon naught by D. This is given to us, this is given to us, and this is given to us. We need to find K, but first we need to find D, then only we will be able to find the value of K. And in order to find D, we can simply do that. The potential will be equals to E into D, or I'll say D is equals to V by E. So what is the value of V? That is 500. What is the value of E? That is 10 to the power 6. As you remember, in the question it is given as 10 to the power 6 and potential is 500. So when you solve this one, you will get D as 5 into 10 to the power minus 4 meters, right? Now C is equals to 15 picofarad, that is 10 to the power minus 12, which is equals to K, unknown to us. A is 10 to the power minus 4, that is Ka epsilon naught. The value of epsilon naught is 8.86 into 10 to the power minus 12, and that should be divided by D, that is 5 into 10 to the power minus 4. Solving this, you will get K nearly equal to 8.5. Let's see which is the best suited option here. Among the 4 options given, option number 3 would be the right answer to this question. I hope this you have understood. Let's move on to our next question, that is question number 12. Now the question you see belongs to section of again communication system, that is modern physics, right? Now the wavelength of carrier waves in modern optical fiber communication network is close to. So this is a fact based question, and mostly the wavelength which is used in optical fibers is 1500 nanometers. So the right answer to this question would be option number 3, right? Now it's time to move on to our next question, that is question number 13.